In this video, we're going to discuss the very first lesson for chapter 2, which is chapter 2 talks about rational algebraic expressions. So imagine that these are just simply algebraic fractions. Algebraic fractions. So lesson 1, the first lesson in this chapter is all about simplifying algebraic fractions or simplifying rational algebraic expressions. Let's proceed with the first example. So we have here 10 x squared y raised to 5 z raised to 6 all over 15 x raised to 4 y squared then z cubed. If we're going to simplify this, we simply factorize each numerator, the numerator, and factorize the numerator. Then we try to by division cancel out those common factors. So here from between 10 and 15, the GCF of 10 and 15 is 5. So we can say that 10 and 5 is 10 is 2 times 5. Then 15 with respect to the GCF 5, you can say this is 3 times 5. Then times x squared with respect to x raised to 4, we can say x squared. X raised to 4 with respect to x squared, we can split x raised to 4 as x squared times x squared. Okay. Then y raised to 5 with respect to y squared, okay? With respect to y squared, we can factorize y raised to 5 with respect to y squared as y squared times y cubed, because y squared and y cubed is just y squared, y raised to 5. Then z6 with respect to z cubed, we can express that as z cubed times z cubed. Then below we have z also cubed. Then that's the time, since we factorize all of that, we try to cancel out by division those common factors. 5 and 5, x squared and x squared, y squared and y squared, z cubed and z cubed. We are left with, in our numerator, we are left with 2 z cubed, and our denominator we have 3 x squared. Done. Our next example, we have negative 24 a raised to 5 b cubed, then quantity a plus b raised to 4. Then we have in our denominator we have 36a b raised to 5, then a plus quantity a plus b square. The same idea, we will factorize 24 and 36. The GCF is 6. So with respect to 6, 24 can be expressed as 4 negative times 4 times 6, and 36 with respect to 6 can be expressed as, no, it's not 24 but 12. Okay, not 6 but 12. So 24 is 2. Let's erase that. The GCF is not 6 but 12. So 24 with respect to 12, we can express that 2 times 12. Then 36 with respect to 12, we can express that 3 times 12. A raised to 5 with respect to a, we can express a raised to 5 with respect to a as a times a raised to 4 all over a. Okay. Then the b cube, the b raised to 5 with respect to b cube, we can express that as b cube times b square. Then above is b cube. So we're just simply factorizing b raised to 5 with respect to b cube, so that we later on we can cancel b cube by division. Then a plus b quantity a plus b raised to 4 with respect to square below, we can express that as a plus b square times a plus b square. Then below is also a plus b square. So above a plus b square and a plus b square, that is simply a plus b raised to 4. Then this is the time that we cancel out those common. That's 1. That is also 1. That is also 1. That is also 1. So we are left with, in our denominator, we are left with numerator 2 a raised to 4 a plus b square. In our denominator, we have 3b square. Number 3. Number 3, it already involves sum, so we need to factor it using our knowledge of factorization in chapter 1. So 2h minus 2, we can factor this as 2h, 2 times h minus 1. Common monomial factor. Then h square minus 1, this is a difference of two squares. H square is a square, 1 is a square. So it's a difference of two square. We can express it as factor as h minus 1 times h plus 1. Cancelling out the common factor by division, h minus 1 becomes 1. We are left with 2 all over h plus 1. Number 4. Y square minus 9 can be expressed as y plus 3, y minus 3. 2y minus 6 can be expressed as 2 times y minus 3. By division, this becomes 1. We are left with y plus 3 all over 2. Last example is we have x square minus 4x plus 4. Note that this one is a perfect square, so we can factor it as x minus 2 square, or you can say x minus 2 like that. You can also write x minus 2 square. Then below, x square plus 3x plus 2. This is a general trinomial, so we can express it as x plus 2, x plus 1. Okay? Canceling out those common, since we don't have, so if we're going to make it plus, this becomes plus and plus. So canceling out those common, we have plus x plus 2 and x plus 2 are left with x plus 2 and x plus 1. That's it.